Welcome back. So today in this video, I would like to introduce you one more word problem relating to the differential equation logistic function yesterday we went through. And the topic today is a little bit different. So that's why I want to show you one more. So let me read the question to you. Now this question is a little bit sensitive because it's related to our real life right now, the problem we are coping. So I hope that you don't feel so sad. Anyway, let me read the topic to you now. I would like to show you this because it's also show you that the reality we are coping in our society is always related to mathematics, science, and statistics. So let me read the question to you. And I hope you can see it for. Okay, so in a small town of 5,000 people, 160 people has COVID-19 at the beginning of the week, and 1,200 have it at the end of the week. Find a formula relating to fraction F of infected people in the town and the number T of the weeks since the COVID-19 was noted. Show that in 11 days, over half of the town was infected. How long does it take for 4,000 people to be infected? Okay, so you see what I mean, right? Now our problem is to solve this and see how it works. This is how our statisticians find out, right? They use on the tools, the mathematical concept, and find out the data accurate as much as possible, right? Okay, so let us get back to that. Now, this question say that find a formula related to fraction F. So it's the key, right? So, and they said that the fraction F of infected people. So let me start by let F be the fraction of infected people. Okay. And we also, in this equation, we also notice that the common sense we build up when we derive the formula is the fraction of infected is proportional to the non-infected. People. Now, in order to establish this proportionate, we have to know, in logistics, we have to know what is our carrying capacity, right? Now, our carrying capacity, K, represent the town of 5,000 people. That's no doubt, right? However, if we talking about the fraction, the carrying capacity convert into 100%. So our carrying capacity actually equal 1 in this problem, right? We assume that 100 people at the beginning haven't infected. So that is 1%. Oh, no, sorry, 100%, which is equal 1, right? So keep in mind of that. Now, we're going to say, therefore, we introduce the differential equation. We'll say df over dt, the derivative of fraction of infected people over respect to time equal a rate of it proportional to non-infected. So we want to find the difference between infected and non-infected, which is with U1 minus N. So that is the first equation, right? Which is makes sense. It's proportional to the rate of growth multiplied with 100% minus 20% or 13% or 60% of whatever infected people, right? So that's our established differential equation. Now we're going to solve this equation and derive the formula. Solve for formula, okay? So how are we going to solve this equation? I'm going to separate the variable again, right? Separate variable. So I will have df over 1 minus f equal r times with dt. Kick this up here and kick this down here, right? That's what the same like I did yesterday. I also can rewrite this as f over 1 minus f df equal r dt. Now I'm going to do integrate both sides. However, before I integrate both sides, I'm going to split this split fraction become 1 over f, adding with 1 over 1 minus f. And yesterday when we went through, we already show why from here down it become here. And actually, if you do common denominator of any fraction, you will see it true, right? Okay. So I'm not going to bother to go through anymore. And we have r dt. So now we'll integrate this both sides. And and this is df. When I integrate both sides, I will have ln of f minus ln of 1 minus f equal rt plus c. Now I'm going to, actually this should be plus, but I want to change this into negative. So I have to twist the fraction, right? If I change it, I have to twist the fraction. That is the rule in logarithmic. We change this, become ln, and 1 over f over 1 now become 1 over 1 minus f, right? I can do that. Now, this will give us, so at this point, what should I do next? Okay, now I'm going to join them together in one log, right? In one log. And in logarithmic, the subtract means divide. That's the rule in log. So I have f on the top, divide by 1 minus f at the bottom. Actually, 1 over 1 minus f, right? 1 minus f. And I can, because it divide the fraction like that, for f divided by 1 over 1 minus f. It's the same like I twist the fraction upside down, right? Turn it over. So I will have ln of 1 minus f on the top, and f now go back to bottom, right? That's how it look like. And equal rt plus c. So at this point, I'm going to raise both sides by e, base e, right? So e to the star equals star, right? But before I do this, I'm going to change this become negative, and therefore everything here will become negative. So now I will have a negative of star, which is 1 minus f. You see, like represents star, e to the ln star equals star. So equal star, and the star is this fraction, right? Equal a to minus rt minus c. But I'm going to change this into time with a to minus c. Now also this e to minus c, can put it back at c because this just represents a constant of c, so I put that there, okay? And actually, when I raise like that, this should be negative, and this should be negative. But now, because they're both negative, I can change it back again, okay? So now, I will split the fraction 1 divided by f minus f divided by f equals c e to the minus rt. And that will give me that will give me 1 minus 1 over f minus 1 equals c e to minus rt. Move the 1 over, I have 1 over f equal 1 plus c e to minus rt. Inverse the fraction both sides. I will have f equal 1 over 1 plus c e to minus rt. And this is the formula I want, okay? Because that will allow us to calculate the infected fraction, because that's the formula of infected fraction, right? So I'm going to erase this. And roughly, I have to need room for this as well to continue with this, except that I'm just leave the formula for now. So now we know our formula. So let's start fresh. We have the formula of f, infected fraction, equal 1 over 1 plus ce minus rt. Okay. So based on this formula, what do we have to do next step? I don't know if you remember. In order to calculate anything, we have to know what our C equal and what our R row rate equal, right? So we're looking for this stuff. And how do we looking for it? We're going to substitute whatever in here we know in the equation to find out. F is a fraction of infected people. At the beginning, we have 160 people infected. And our fraction of that will be 160 divided by 5,000, right? Because we're talking about the fraction. F represents this fraction. Will be equal 1 over 1 plus CE. Now, at the time T, when 160 people have infected, that time at the T equals 0. Right? So now we substitute t equals 0 in here, this is like e to the power 0. And now we can cancel because e to the power 0 is just 1, right? So it's just like 1 plus c. So now let's find out what this number is. I'm going to cancel 1, 0, cancel 1, 0. So we have 16 divided by 500. 16 divided by 500. So I got 0.032. So this is 0.032 equal, no, I'm gonna kick this bracket up here, right? So time with 1 plus c equal 1. So what does that tell me? I mean, I can bring this over here, divide it, right? And cancel this 1. So 1 plus c will be equal, this number divided by that number, 1 divided by 0.032 equal 32.25. So c will be equal 32.25 minus 1, right? Cancel that. So that equals 31.25. So that's the value of C now we know. So now what's the next? Next, we have to find R, right? To find R. So what is our R and based on what? value, we can find R. Now it say that at the end of this week, 1,200 people have it. So the fraction of infected people by F here, we'll replace it by 1,200 divided by 5,000 equal, follow the formula, 1 plus C A to the minus R times T. And T is say at the end of the week, so we know the unit time is week and we can substitute by 1 here. So now let's divide 1 to 100, divide by 5,000. We got 0.24 equal this over this minus R. Now I'm going to kick this up again. So 0.24 times with 1 plus C. And now C, let's substitute the C here. C is 21.25. A minus R equal 1. So divide both sides by this number. This gone equal 1, and this will be 1 divided by 0.24 equal 4.1666 repeated. So now I will write like this, equal 4.166, right? Now I'm going to move the 1 over here, and it means I subtract when I move, it gone. So now I will divide both sides by 31.25, right? So I will get this number is minus 1 and divide by 21.25. I get E to the minus R equal 0.10133 with the bar on top. Okay, so now we know what our R equal. This is our R. Now, can we round off this number? It equals 0.1013. I just round up like that. Okay. Actually, hold on, not yet. Just leave it for now. I'm going to take log both sides, right? So when I take log both sides, minus R equal log of this number. So let's take log of this number, 0.1013333. So minus R equal minus 2.289. And this is I round off become minus 2.23. Okay, now this both negative, so we change it become positive, both of them. So this is the R value. Now we know. So we can look back this into our formula. Our formula now will become F equal 1 over 1. C is 31.25. And E to the minus R is this number, 2.23 T. So this is our formula now, okay? So, I'm looking for, yes. So I'm gonna erase this so that we have room. Now, what do we do next? So this is the, we answer the A question. This A question can be this or be this as well. This is our formula, answer for A, okay? Now I'm gonna find out the answer for B. Show that in 11 days, over half of the town was infected. It means more than 50% of people. If we can prove that this formula is correct, we're gonna substitute the T in and find out, is that 50% or more than 50% people infected, right? in 11 days. But remember the different unit, right? We have 11 days over the week, and 1 week is 7 days, right? So to convert to week, you have to divide it, right? So 11 over 7 days will give us the week, right? Because the days we cancel out and we left with the week unit, 11 days divided by 7. Yeah, because we have 7 days a week, right? So to convert 11 days, to convert to the week unit, you divide it 11 days divided by 7 days, okay? Now I'm going to just leave it like in fraction rather than chain it, right? So just leave it for now. I'm going to find out, is that fraction is the rule that is at over 50%. So we have a formula f equal 1 over 1 plus 31.25 e to minus 2.323 times with t. So now we're going to find out, right? We already know 11 days. Let's find out how much the fraction will look like. So we have 1 adding with 31.25 e minus 2.23, substitute t by 11 days, divide by 7. And let's see how much the fraction will be. So because this is complicated, so I'm going to do this group first, right? So what I'm doing here, I'm going to show you how to do on your my calculator as well. So you learn the way I do it if we have a complicated fraction like that. So whatever complicated, I'm going to do this first, okay, to get rid of it. So I'm going to key in 31.25 and the second e, I got the e value right on my calculator. To the power, I'm going to open the bracket, minus 2.23 times with 11 and divide by 7. So I'm going to close the bracket, I'm going to enter it. So this is the number we get, right? But remember, we have to add this number with 1 here, right? So I'm going to add into 1. Add 1, enter, and we get this, right? But we know that we have to inverse this fraction, right? Because we do the bottom first, but this is supposed to be 1 divided by this number. So I'm going to hit the inverse button on my calculator, x to minus 1 on top. If you have a roughing calculator, this is what you do. Otherwise, you can just key back again, 1 divided by this number, right? But I'm going to do that on my calculator. I hit inverse. And yes, we got 0.5155. I'm going to round off, become 2, right? Multiply with 100 because this is a fraction, right? So we get 52% of infected people after 11 days. So that's true. We just show it. We should show that, yes, over half of the town, 52%, with you. So our formula developed is correct, right? 52%. So that's how we solve for B, right? Now, I'm going to show you how to solve for C. So we get this answer, and this is proven, right? Over proven. Over half of the town, 52% infected. Now we're going to do C, okay? And do C is just easy. Maybe you can do it, right? Maybe I can stop here and let you try, but let me see. Let's finish this question now. So we have C now. We say 4,000 people to be infected. We want to find out how long this take, right? So again, we know the fraction. 4,000 divided by 5,000. That is represent the F, right? Equal 1 over 1 adding with 31.25 minus 2.23 times with t, and we want to solve for t, right? So I'm going to cancel 0 here, 0 here, cancel. So this fraction is 4 divided by 5. 4 divided by 5 equals 0.8. So 0.8 equals this. And I'm missing the e here, minus 2.23 times t. We want to find out this, right? So I'm going to kick this root up here. So 0.8 times with 1 plus 31.25 e minus 2.23 t equal 1, right? Equal that number. Divide both sides by 0.8. So that gone when I divide it, right? So 1 divided by 0.8, I got 1.25. So this number equal 1.25, okay? So now, subtract 1, right, both sides. I'm gonna minus 1, and that gone when we subtract. So this equal 0.25. So now we know 31.25 e, the minus this, equal 0.25. So now what do I do next? Divide both sides by 31.25, right? That gone. So I have e minus 2.23 t equal this number divided by this number. Divide by 31.25. I got this number equal 0.008. So now I take ln both sides, right? I have to take ln both sides. So ln e to the star equals star, so equal minus 2.23 t equal ln of this, 0.008. Now divide this number by minus 2.23, so that gone. T will be equal this ln divided by that. So I'm going to take ln of 0.008 and divide it by minus 2.23. I got the answer t equal 2. I'm going to show you, right? Okay, so 2.16. And what is the unit for this? So the time here equal represent the weeks unit, right? So this is the weeks. Now, if we multiply with 7 days, we get unit in days, right? And maybe better, so I'm going to times 7. So it take about 15 days. So the pandemic spread very quick. If it's 11 days, over half of the town have infected. If it's 15 days, then how many people? 4,000 people to be infected. So in 15 days, 4,000 out of 5,000 be infected. So if we want to convert that, we also can say 4,000 divided by 5,000, which is 80%, right? Yeah, 80% of people infected, okay? So that's how we answer this question. And I think that in the dry tie, I am doing this question now related to our pandemics around the world, the COVID-19. Very sad situation, but we see that statistics can use the logistic function to figure out how many people infected, how many percent, what the fraction of infected people, in what times, how long this take, right? So it's very straightforward, practical question, problem solving, apply to our daily life reality. So I hope that you understand about this topic very well, because I showed you yesterday and today already. Now, student, whoever graduate from Math 12, probably will digest this concept. Now, for some of you, if you just watch randomly on a YouTube, you might get some idea, but at least you will see how mathematics related to our real world problem solving, and it doesn't hurt to explore new idea every day. So I hope that like I think that because the technology gives us the advantage to improve our life, to open the education to everybody, regardless you are in the field or you're not in the field. You see what's going on, what is the news idea, and you be familiar with it. Maybe it's just for gaining the knowledge, but however, I believe math is contribute a lot to our society and teachers and everybody. Now, I myself, it's not because I am a teacher, so I appreciate teacher. Even though when I was a child, I look up my teachers. I don't know because of the culture is embrace me into that environment or not, but I used to sit down on the desk, I remember, and I always took the first front row. Now I became a teacher. Now I ask my student, come in, like sit in the front so you can see the board. They just try to move back to the back. It's opposite with what I was doing before. Before, when I was a child, when I learned, I always try to get into the classroom early, sit right onto the front desk because I'm afraid I cannot hear anything. And in our classroom is 30 students, 40 students, right? So it's very crowded classroom, and I have to sit in the front so that I don't miss anything. Now, but in that time when I sit up, I sit there and I was looking up at my teachers. I don't know if I still have that feeling right now or not, but at that time I just look at my teacher and I said, oh, why are he talking about so much thing I didn't even know? How could he remember a lot of stuff like that? And I so admire my teachers, like, and sometimes we have a very strict teachers. If we just open our mouth, he just toss us out of the classroom. It's not like right now. The kids can kick the teacher out of the classroom if we yelling at them or something. It's totally opposite environment and opposite the perspective how we treat teacher before and nowadays. And I just remember, like, I dare not to open my mouth for a little thing we just want to exchange. But I was so admire my teacher at the times. I said, oh, it's like he's like my ideal, like Michael Jackson, like to all people around the world now, like Michael Jackson. And I look at my teacher at that time like a Michael Jackson, and how could he do like that? How's so talented? How could he know all the knowledge and I didn't even know? And how could he talk everything from his mind? Like even didn't have to look at the papers and things like that. I just so admire and respect my teacher, to be honest. And that's why I when I grew up, maybe I want to be a teacher. Well, I try my best to be a good teacher. I hope. Okay, so thanks for watching. I hope you enjoyed my video. See you next video.